So we've gone over bonds, right? So you know ionic, covalent. So when we get to naming stuff, here your view is of Mr. Bacon. Mr. Bacon's one of my favorites, and my daughter drew this. I thought this was quite nice. So let's get into what's going on here. Naming stuff has everything to do with three basic things. Number one, there's ionic stuff. There's covalent, or sometimes called molecular stuff, and there's acid stuff. We're going to leave the acids out for right now and just work on ionic and covalent naming. In other words, if I give you a formula, how would you name it? So let's just say CO2 and NaCl. The first thing you have to decide when you're naming things, because there's two different naming conventions or naming techniques, is it ionic stuff or covalent stuff? So remember, ionic stuff is a metal and a non-metal stuck together. Covalent is a non-metal and a non-metal stuck together. So this guy right here is covalent or molecular, and this guy right here, he is ionic. So there's two different techniques. Now, CO2, you know what to call CO2. The name for that is carbon dioxide. The name for NaCl is not sodium monochloride, it's just sodium chloride. So the basic difference here is when you're naming things, ionic stuff just gets the name. When you're naming covalent stuff, you use prefixes. So let me take you over and show you that, show you the steps. So the first thing you need to know when you're looking at naming stuff is anytime something is covalent, you need to know a set of prefixes. So go ahead and get these in your notes if you would, please. Most of these you know. One is mono, two is di, blah, 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 blah. Number 4 is tetra, and you probably have learned quad before. Tetra is just another prefix for 4. You've heard of the game Tetris, and a Tetris is where you cleared 4 lines of blocks all at one time. That's why it was called Tetris. And then the rest of them are pretty normal. Hepta sometimes gives people fits, and a lot of y'all don't know 9 nana. So go ahead and get these in your notes. All right, for molecular stuff, this is what you guys need to be able to do. For molecular stuff, what you do is you write the prefix plus the first element, and then the prefix and the second element. So let me give you one, and you guys can see if you can do this or not. N2O. That's molecular stuff. Prefix plus the first element. Now, there's 2 nitrogens. So you say 2 nitrogens would be di-nitrogen, and then the prefix and the second element make it end in IDE. So this would not be monooxygen, it would be monoxide, okay, or monooxide. So this would be dinitrogen monoxide. Now, just a note, if it sounds funny when you say it like monoxide, typically we shorten it. But we don't like to say monooxide, so we just say monoxide. But the first one keeps its name, nitrogen. The second one ends in IDE. If you think about that, you already know that. It's carbon dioxide. You already know how to do that, right? These are the easiest ones to name in the world. All you have to do is write the prefix in the first element, prefix in the second element, and we always leave off mono if the first one is mono. That's all you have to do to name molecular stuff. Ionic stuff. Well, ionic stuff is a little bit more complicated, but still it's fairly straightforward writing the names of it. There are some things that are binary, meaning just 2 things. And so it looks like this. That's binary. FES, binary, 2 elements. If it was 3 things like that, that's 3 elements, that would be ternary. Write the names of the individual ions using Roman numerals for transition metals. What's Fe? Iron. What's S? Well, let's take a moment and look at the periodic table. If you go ahead and haul out your periodic table, I'll go ahead and haul out mine. The periodic table here, you guys know that this part over here, that's metals, right? And this part over here, this is non-metals. Metals always keep their name. That's iron, that's molybdenum, that's titanium. Nonmetals, on the other hand, when they turn into ions, we make them end in IDE. So this nitrogen would be nitride. Oxygen would be oxide. Fluorine would be fluoride. Phosphorus would be phosphide. Sulfur would be sulfide. You get the idea. If it's ALO, then it would be aluminum oxide. The other thing we have to look at is this section here in the middle. We don't know what the charge of these guys are. That's because they tend to have many charges, right? So iron can be a +2 or a +3. Anything that has multiple charges, in other words, anything when you look at your periodic table, if you can't tell me what the charge is, you have to use a Roman numeral to tell me what the charge is. So you can't just say iron. You need to say iron 2, Roman numeral 2, because that tells you that it has a charge of +2. If I say copper 1, then it would be copper with a +1 charge. Write the names of the ions. So this would be iron sulfide. Now, is iron something you know the charge of? No, you don't know what the charge is on your periodic table we labeled in class. Iron sulfide. So what we have to know is what is the charge of the iron. In order to do that, you just have to understand one basic idea. The charge of the iron and the charge of the sulfur have to add up to equal 0. In other words, they have to cancel each other out. So let's look and see what that looks like. Let's see. FeS. Sulfur's a -2. And you know that together they have to add up to equal 0 to cancel out. So what does the charge of iron have to be in this case? That would be +2. So the correct name for this puppy would be iron 2. The technical way is to put it in parentheses, sulfide. So let me give you another one. Let's go Al2O3. Let's say I gave you that formula and I asked you to name it. Well, go back to your steps. What does it say? Write the names of the individual ions. Use Roman numerals if you have to. Well, what's Al? Aluminum. Aluminum. What about O? That would be oxide. Aluminum oxide. Now, do you have to use Roman numerals? Well, go look at your periodic table. Did we label what the charge of aluminum is? Yes, aluminum is a +3. Since aluminum is a +3, we don't have to show its charge. We know what its charge is already. So you would make this aluminum oxide. I know what you're asking. Some of you are going like, wait a minute, what about prefixes? What about those prefixes? Aren't we supposed to say dialuminum trioxide? No, you're not. Well, why not? Well, let's go back, look, one more time. If it's molecular stuff, 2 nonmetals, then you use prefixes. If it's ionic stuff, you don't use prefixes. Remember how I said you had to know whether it's ionic or molecular? That's why. That's aluminum oxide, no prefixes. I know what you're saying. You're saying, well, where did the 2 and 3 go? What happens to them? Well, in the next podcast, you're going to learn that those 2 and 3 I can make magically appear. So for right now, just name them what it is, aluminum oxide. And in the next podcast, I'll tell y'all how to write formulas. If I give you the name, how do you write the formula? Trust me, it all works out. For ternary ionic stuff, you're going to do the same thing. You're just going to name what you see. For ternary ionic stuff, there's not a whole lot of difference here. So let me just go ahead and give you one and you guys can go, oh, okay, I know what that is. NaNO3. Now, you guys know that Na is sodium. That's easy enough. NO3, what's that? NO3 is a polyatomic ion. You wouldn't say it's nitrogen oxide. You would call that nitrate. The nitrogen and the 3 oxygens stay together as one unit and have a charge. So that would be sodium nitrate. You just name what you see. So let me give you another one. You guys will see how you do. MgNO2 parentheses 2. If I give you that, I ask you to name it. Just name what you see. Magnesium, NO2, nitrite. Magnesium nitrite. But wait, there's a 2. I don't care. I don't want you to use prefixes. I don't want you to go magnesium dinitrite. Magnesium nitrite. Don't worry about the two. Trust me, it comes out. Just name what you see, magnesium nitrite. For molecular stuff, use prefixes. For ionic stuff, no prefixes. Let's say that I give you this. Let's say I give you PbS2. And I ask you to name that. Well, this is lead. That's easy enough. This is sulfide. Now, lead, though, if you look on the periodic table, lead is one of those metals we don't know what the charge is. So we need a Roman numeral here. It's supposed to be a question mark. We need a Roman numeral there, and we don't know what that Roman numeral is. So just remember, whatever lead is, plus there's two sulfurs, two of whatever sulfur is, that those charges have to add up to equal 0. So whatever lead is, plus what's the charge of sulfur? Look on your periodic table. Sulfur has a charge of -2. Whatever lead is, plus 2 times a -2 is equal to 0. That means lead has to be a +4. So you would say Roman numeral 4. So that'd be lead 4 sulfide. Let's give you another one. What's one of my favorites? How about CO3N4? What would you name that? That would be cobalt. This would be nitride, because the second one ends in IDE off the periodic table. And then what goes here in the middle? Well, what goes there in the middle is some kind of Roman numeral. So 3 times whatever cobalt is, plus 4 times whatever nitrogen is, has to equal 0. So 3 times cobalt, what's the charge of nitrogen? Nitrogen has a charge of -3 is equal to 0. 3 times cobalt plus a -12 is equal to 0. That means 3 cobalts has to equal +12, which means each cobalt is +4. So that would be cobalt 4 IV nitride. So TiSO4 parentheses 2. That is titanium. That part's easy. Sulfate, one of your polyatomic ions. And I need to know what is my Roman numeral there. Titanium what sulfate? Well, titanium sulfate, it'd be whatever titanium is, plus 2 times whatever sulfate is. Sulfate, look up the charge, is -2, is equal to 0. That means titanium has to be equal to a +4. So that's how you figure out the charge of those bad boys. All right? We'll practice the rest in class.